Hello everyone. Now in this fourth example, if you notice I have an x on both sides of the inequality. When this happens, the same rules apply. The first thing I'm going to do is find my critical values that will make the denominator equal 0. So in the first fraction on the left side, if I plug in -1 for x, that denominator will be equal to 0. And it's still going to be an open circle. In the second denominator, if I plug in 1 for x, it's going to make the denominator equal 0. And that's still going to be an open circle. To find my other critical values, I will cross multiply like I did in the other problems. So 2 times x minus 1 is going to give me 2x minus 2. And 3 times x plus 3 is going to give me 3x plus 3. And then I will solve for x. So I'll subtract 2x on both sides, and I'll get -2 equals x plus 3. And then I'll subtract 3 on both sides. And then my answer will be x equals -5. So that's going to be my third critical value. Since in the problem I have that equal to, this is going to be a closed circle. So I'll go over and draw my number line from -infinity to infinity, and 0 is still in the middle. In this case, I'm going to have 3 critical values. So when I plot them on my graph, I have -1 here, 1 here, and -5 over here. At -5, I have a closed circle, and at 1 and -1, I have open circles. I can still just choose one value to test when I plug in the number for x, and I'm going to plug in 0 for x. So when I do that, I have 2 over 0 plus 1, less than or equal to 3 over 0 minus 1. So over here on the left side, I really have 2 over 1, which is 2, less than or equal to 3 over -1, which is -3. When I look at this statement, I have to ask myself, is 2 less than or equal to -3 true or false? This statement is false. So since I plugged in 0 for x, in the interval where 0 was, I'm going to write false, and it will still alternate. So this will be true, this will be true, and over here it will be false. I'll only shade where it's true, and my final answer will be from -5 to -1, bracket because it's closed, parentheses, and from 1 to infinity, parentheses.